The graphs of sine and cosine are directly linked to each other. What I mean by that is they are very, very similar to each other in terms of what they look like. There's just a little bit of a difference between them. Looking at specifically, let's jump to sine of x first. Looking at the sine of x, just to kind of give you an idea here. The first vertical line that I have there is at pi. The second one is at 2 pi. So if you think about it, from 0 to 2 pi, that is one go around the unit circle, which would make sense that one complete wave is completed within 0 to 2 pi. So looking at this, it starts at 0, 0, ends at 2 pi comma 0, again based off of our unit circle, and one whole wave takes a length of 2 pi. Cosine, on the other hand, a little bit different, but pretty much similar. Cosine starts at 0, 1 and ends at 2 pi 1. Again, takes one whole wavelength from 0 to 2 pi, and again that makes sense because of the unit circle. Notice both waves in terms of their height have a range from -1 to 1, and again it's based off the unit circle, so that would make sense because the largest number on a unit circle is 1. It's 1 unit. The smallest number is -1. So looking at our notes here, sine of x versus cosine of x. So sine of x, the domain is all real numbers. Same thing for cosine. The range is a closed or a bracket from -1 to 1 for both of these functions. Oh, as I just put a parenthesis, sorry. One wave. So wavelength equals 2 pi. And like I said, this one starts at 0, 0. Cosine starts at 0, 1 and goes from there. Otherwise, they don't have any undefined spots. Everything just shifts as you add 2 pi onto this. Now, that's just the basics of sine and cosine. There are times when you have numbers and things that are going to stretch, shrink, move it up, down, left, right, and we need to talk about that specifically. The same, it doesn't matter if you're in sine or cosine, this is the same concept between the two because they are so intertwined together. Let's say that we have y equals a. I should put that not as a parenthesis there. Sorry if you're writing in pen. Sine of bx plus c, and then we'll just go with plus d. So we need to talk about what is a, what's b, what's c, what's d, what do they mean, how do we find it if I don't have a graph, and we'll double check with our different graphs here. For instance, a represents amplitude. Amplitude is how tall your graph is. So it's kind of like your height, but it's cut in half because if you notice with the sine function, it went from -1 to 1, but the amplitude of that would be 1 because if you cut that in half, it's in 1. So make a little note here, cut in half for total. Okay, so B, now B is kind of tricky. B is the trickiest one of them all. B represents the number of waves that you're going to complete within 2 pi. That is if it is in the form of the absolute value of b divided by 2 pi. Okay, so this one, like I said, is the trickiest one. C represents a phase shift. Okay, and it has to be negative C because it's opposite of what we see because it's inside those parentheses. This is going to tell you whether it's left or right. And then last but not least, D is your vertical shift. This one does not go opposite of what you see. This is going to determine your up and down, which is a little bit easier to depict. So let's actually look at an example of this and figure out some of the information and see if we are correct. So let's say that I have the equation y equals 4 sine of 3x plus pi over 2 plus 1. So I'm going to go through and pick out the easy ones first because, like I said, the phase shift and number of waves that occur is tricky. So our amplitude is going to be 4. Our phase shift is going to be negative pi over 2. So it's going to be going left. Our vertical is going to be a positive 1, which is going to represent up. And then, like I said, the tricky one is our number of waves or our frequency. So it shows as a 3, and I told you guys that this is b over 2 pi. But if we're talking in terms of 2 pi, this is technically going to be the reverse of this. So we want reverse due to waves in 2 pi. Okay, so this is actually going to be 2 pi over 3 is where this is going to complete one wave. Okay, so it's kind of tricky to think of it that way. But again, it's because the frequency, if you have it as this absolute value of b over 2 pi, that's going to represent the number of waves in 2 pi. But if we're looking for one complete wave, then you just reverse it and do the reciprocal, which is going to give you 2 pi over 3. So let's look at the graph and see actually how this looks. I have the original on there in the sine of x. So looking at that 4 sine of 3x plus pi over 2 plus 1, we can see off of this graph that this is going from negative 3 to 5, which would give us a total distance there of 8. But like I said, cut it in half, and that gets you your amplitude. Looking at, so if I look at the 8 and divide it by 2, I get 4. So if I cut that and actually count down my 4, this is going to give me my vertical shift of a positive 1. So we did good there. The tricky one to see, so it's tricky to find the number of waves to find that length. But then if you're looking at the graph and going the reverse way, it's kind of tricky to see the shifting left and right because you're either stretching or shrinking it and that kind of stuff. Sorry, just going to erase this so you guys can see the full picture here. Looking at this, we're going to be shifting over that pi over 2, which, oh, come on, fish. Didn't put it on here. So let's see. X equals negative pi divided by 2. We'll graph that vertical line there so you guys can see what happens. So notice this point here is supposed to represent where my starting point is. So that point there shifted it left. It shifted it left negative pi over 2. And then last but not least, looking at our complete wave, you guys can see on this graph from here to here, I completed one whole wave. But if I was looking at the whole picture to 2 pi and how many I have there going on, we can see that if this is our starting point, we completed 1, completed 2, completed 3. Completed 3 whole waves within that 2 pi. So you're going to use this information to figure out the different graphs and how it affects the graphs, and you might even have to go the reverse way in order to figure that information out.